check, 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 check. Check one, check, check, check. Check. Online students, can you hear me clearly now? Online students, can you hear me clearly? Can someone please confirm? Okay, thank you. Check, check. Jennifer, the sound is too much. Okay, okay. Too much. Check, check. Okay, so last week we started with units and dimensions. As I remember, we did some questions from dimensions, so I think we have to continue with dimensions. Are there students who don't have tutes? Are there students who don't have tutes? Okay. Who need tutes? Anyone? Okay, okay. No, no, tutes. Minaga? Minaga? Check sounds. No, check sounds, not enough. Not clear enough. Minaga, check sounds, not clear enough. Okay. So, check. Okay. Okay. So, this is a question given to me by a student in Sunday class. So I'll start with this question. S equals S equals. I'm not sure like the source of this question. A student from Sunday class gave this question. So let's start with this question. AT squared, AT squared, 1 plus half BT. AT squared, 1 plus half BT. I actually don't know the source of the question, but it's a nice question. So let's start with this one. The question is, I actually exactly can't remember the, did we do this question? Yes, in the class? Really? Did we do this question last Thursday? Something like this? Anyone? No? Okay, anyways, you can start with this question. I'll change the values a bit. This is displacement. Attention. This is displacement. This is displacement. This is displacement. That means dimensions is length. Dimension is length. This is time. T is time. T is time. So you know the dimension of time. What I need you to do is find dimensions of A and B. Find dimensions of A and B. Quickly try to get these values. Find dimensions of A and B. Find dimensions of A and B. So your tutes will be distributed now. Tutes will be distributed now. And for online students, the tunes will be given in the Zoom chat and to WhatsApp groups. Okay, there are some new tunes, I think. So if you have to get the workbook, units and dimension main theory book, and this paper where you have to fill blanks. So if you don't have any of the tute, just inform and collect the required tutes. If you need any of the tutes, just inform the coordinators and collect your tutes. And for online students, everything will be available online within 5 minutes. S is displacement here, S is displacement, T is time. T is time. I think it's enough data. Yeah, it's enough data. I need you to find dimensions of A and B. We started dimensions last week, but we didn't do much, right? We didn't do much. We had to analyze the use cases of dimensions. There's a lot to analyze like that. We didn't do that part. So let's continue with that part. But let's first, still some students are coming to the class. So let's start with 1 or 2 questions, then continue. And if you miss the paper, again, if you miss the paper, for online students, every day there's a paper before the class, 1 hour paper. So the class starts at 3. So there will be a paper from 1:45 to 2:45. It's not mandatory. Okay, it's not mandatory. If you like, you can write. Otherwise, you can wait until you are ready. Okay. A small paper which you can use to, attention everyone, attention. A small paper which you can use to revise last week's content. Okay. A small paper to revise last week's content. But anyways, if you are missing, if it is not possible to write the paper before the class, you can write the paper after the class. Okay. For online and physical students, and anyways, if you don't like to write the paper, you can wait until you are ready. Okay. It's just for you to check your knowledge. Okay. And the papers, you can write the paper before the class, and your marked papers will be given at the end of the class. Okay. So all the papers, marked papers will be distributed at the end of the class. Okay. And for online students, your corrected paper will come to you as I think through the Google form or as an email. Okay. So quickly try to get the answers. Check, 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 check. Now it's good. Okay, so attention. So how can I get the dimensions? I can only analyze this part first, right? I can analyze this part first. I don't have to think about, I don't have to expand or do anything. Why? This is 1 plus something, right? This is 1 plus something. So 1 is dimensionless, right? Here 1 is dimensionless, right? Clear? 1 is dimensionless. So I don't have to like expand or do anything like that. Since this 1 is dimensionless, this whole part must be dimensionless, right? Is that clear? You can't add 5 with 2 meters. Okay, if you're adding 2 quantities, they must have same dimensions, right? So if this is dimensionless, this part must be dimensionless, right? Clear? If this is dimensionless, this part must be dimensionless. Clear? So the dimension of this part, half bt, dimensions of this part, half bt, it's 1. That means it's just dimensionless. Clear? Ah. So half bt, this part is dimensionless. Then what? Then what? I can break this into parts, right? Half, then dimensions of b, then dimensions of t equals 1. Half, it's again dimensionless. It's again dimensionless. Then I have dimensions of b, dimensions of t, t is time. That means capital T equals 1. Capital T equals 1. Then I get dimensions of b, dimensions of b as 1 over t. Clear? I get dimensions of b as 1 over t. Clear? Everyone? Okay. Then if dimensions of b is 1 over t, now this is dimensionless, this is dimensionless. So the whole part must be dimensionless, right? When you add two dimensionless quantities, if this is dimensionless, if this is dimensionless, when you add two dimensionless quantities, clear, you get something without a dimension, right? So this whole part is dimensionless. Clear? This whole part is dimensionless. Clear? If this whole part is dimensionless, dimension of this part must be equal to the dimension of this part, right? Clear? Dimension of this part must be equal to the dimension of this part. Why? I can forget this part. Why? It's dimensionless. Clear? So dimensions of S, dimensions or dimensions of S, dimensions of S equals dimensions of AT squared. Clear? Clear? Why? I can forget this part, right? Clear? Then S A, then T squared. What is the dimension of S? It's a length. It's displacement. Displacement is a length. So dimension of S is L. Dimension of A, I had to find. Dimension of T, capital T, right? So it's A T squared. Clear? Then I get A equals what? L over T squared. L over T squared. That means L T minus 2, right? L T minus 2. Clear? That's how I can get dimensions of A and B. Clear? Write this down. Then let's start with uses of dimensions. Mali, check sounds in online. Minaga, check sounds online. Both YouTube Live and Zoom. And please, do provide all the tunes again in the WhatsApp group and Zoom chat. And if anyone need any assistance, anyone need to join the groups, if anyone need tunes or any information, you can contact this number. If you need tunes, any assistance or anything, you can contact this number. Not 70, not 70402, not 70402, not 70402, 9701, 9701, not 70402, 9701. You can contact this number if you need any information or tunes or anything like that. Okay, so let's start with the uses of dimensions. Attention. Hope everyone, okay, if quickly write this down if you are still writing. Okay, and as I always explain, I mean, use the same class to improve your writing speed, okay? Use the same class to improve your calculations. Use the same, bring your logbook every day. Bring your logbook every day. Use the same class to do calculations, like quickly try to finish the calculations. Why? You don't get any time at home to do this again and again. So just make it a habit to get the final answer whenever you are doing something. Make it a habit to go to the final answer in the class, okay? Then you get that habit of finishing a question, okay? Okay. Then whenever you are writing, try to write at your maximum speed. with enough clarity, with enough clarity. Why? So when you keep pushing like every boundary, your writing speed, your calculation speed, your accuracy, when you keep pushing every boundary in the class, okay, without even knowing, okay, you improve, okay, you improve to I mean you can move to a higher level, so that I mean the term test and A levels feels effortless, okay. So that is the basic requirement here, okay. So like whatever the boundaries, try to push them in the class. Even writing speed is also a boundary, okay. Why? I mean, I explained this last week as I remember. If your writing consumes 1 hour of your paper, I mean, you work for A levels maybe for 2.5 months. Okay, if your writing time is like 10 minutes more than your friend, that means to write the whole paper. If you take 10 minutes more than your friend, it it's equivalent to like 2-3 months of your life, right? Okay, why you work for 2.5 years for 3 hour paper? So just do your own calculation, the worth of 10 minutes, okay? So if your writing time can save you 5 minutes, okay, it actually it's equal to like 1 month of your life or something like that, right? So writing speed matters, calculation speed matters, okay? Whatever the speed you can perform in a paper, it matters, okay? So try to push every boundary in the class, okay? Ah. I mean, we are not supposed to tell the bad side of A levels, the difficulties of A levels, how much you have to work in the A levels. As a convention in the tuition industry, people don't tell this stuff at the beginning so that students move to commerce without doing science. But I mean, that's the reality, okay? There's a lot to do. There's a lot to do. Why? At the end of the day, we are trying to figure out who are the highly capable students who deserves to be maybe engineers, maybe doctors, maybe scientists, people like that. So all these industries are industries that you have to work over time, that you have to like push your boundaries, okay? There's a lot to do in this industry. So after the process of A levels, what they try to like, they are not they, they are not looking for students who are capable of doing physics, maths, and chemistry and IT or something like that. They are just trying to find the students with suitable personality. Clear? The students who have the right personality to be someone like engineer, doctor, or scientist, or someone like that. Okay, that means a person who can work hard, a person who is really accurate. So 1 or 2 careless mistakes can cost you like maybe, I mean, definitely 2-3 careless mistakes in the paper, your A result, if you were going to get an A, it will move to a B, right? It will move to a B. And I mean, it's correct. Okay, it's correct. Why? I mean, a person who's looking to be a doctor can't afford to do at least 1 careless mistake, right? So accuracy matters, okay? Accuracy matters. So it's good that you lose marks when you do careless mistakes, okay? That's how it's planned, okay? So after 2-3 years, through the exam called A levels, what they try to figure out is who are the people with the correct personality, okay? Not just a set of random students who are good at writing, who are good at physics, maths, bio, chemistry. No, it's not the case, okay? Okay, so next part. So uses of dimensions. Let's start with uses of dimensions. Okay, so this is the case. Last week we learned about attention, everyone. I need everyone to pay attention. Okay, last week, we discussed about dimensions. We started with the concept called dimensions. Attention, everyone. I still hear people speaking. Attention. Last week, we started with the concept called dimensions. So it's nothing new. It's nothing new. It's how things are connected with basic physical quantities, right? I mean, we just gave symbols to fundamental physical quantities, right? There was a fundamental physical quantity called mass, okay? There was a fundamental physical quantity called mass. We gave the symbol called capital M, clear? There was a fundamental physical quantity called length. We gave the symbol L, okay? There was a fundamental physical quantity called time. We gave the symbol T, clear? Then how many dimensions can we have altogether? 7, right? we can go up to, there are like 7 fundamental physical quantities, right? There are 7 fundamental physical quantities, so we can go up to 7 dimensions, but these are the main dimensions that we analyze in our syllabus. So as a result of these symbols, now we can analyze any fundamental, I mean, any derived physical quantity and understand how it's connected to fundamental physical quantities, right? That means if someone tell me that there's something called velocity, if someone come and tell me that there's something called velocity and its dimension is LT minus 1, okay? If someone all of a sudden come and tell me that there's a think you have no idea about velocity, you don't know what is velocity, but then someone tells you that the dimension of this physical quantity called velocity is LT minus 1. Clear? Then you know that it's length divided by time, right? See? So using this symbol, using the set of symbols, now I know how derived physical quantities are connected with, okay, how derived physical quantities are connected with fundamental physical quantities. Clear? That is the basic idea. So this is not the only case, okay, that we have to consider about dimensions. There's a lot of there's a lot of use cases of dimensions, okay. For an example, let's start with the first one. I take the example B. Okay, I'll take the example B. This is Newton's law of gravity. Okay, Newton's law of gravity. As I always tell, our syllabus is, Newton physics entirely. So they identified if there are two planets, one is capital M, one is simple M, the gravitational force between them, okay, the gravitation, I'm just explaining how things evolved, okay, how things evolved using dimensions. Okay, if there are two, if capital M and simple M, they identified that there's a certain gravitational force between them. There's a certain gravitational force between them. This is what holds this system. Okay, and they identified that this force depends on definitely capital M and again simple M. They identified that it depends on capital M. That means larger the capital M, larger the force. Through several experiments, they identified that. Then larger the simple M, larger the force. Clear? They identified these things. Then they identified that when this distance is higher, when the distance between these two planets go up, okay, then they identified that this force goes down. So through experiments, they identified that this gravitational force between objects goes up with the mass, goes down with the distance, okay. But the problem was, whatever they do, they didn't come up with the exact value. That means when you put capital M, exact value of capital M here, exact value of simple M here, and the exact value of radius, not radius, sorry, the distance here, we still don't get the force that we calculate or the force that we measure. So there was something missing, okay? There was something missing, okay? In these kind of scenarios, okay, there was something connecting these two sides, okay? There was something connecting these two sides, okay? That's how they analyzed, okay? They do several experiments, then they find correlations between different quantities. But the problem was there was something connecting them, okay? When it is difficult to find who's connecting them, the best solution is, first thing that you can do is analyze dimensions, right? Analyze dimensions. So they assumed that something called G is connecting them. Clear? Then the first thing they did was analyzing dimensions of G. Analyzing dimensions of G. So F equals G capital M simple M over R squared. Then what is the derivation of force? Just change in your tute. It's not MLT minus 1, it's MLT minus 2. MLT minus 2 equals G. Capital M is a mass. Simple M is a mass. R is a distance. R is a distance. Capital M is a mass. Simple M is a mass. R is a distance. Then I get G equals dimensions of G equals ml t minus 2 L squared over m squared. Then I get m minus 1 L cube, m minus 1 when I solve these two, m minus 1. Simple m is a mass, capital M is a mass, r is a length, force, dimensions of force, ml t minus 2. Then I get dimensions of G as ml cube, here t minus 2. Yeah, that's all. M, here I have m, here I have m squared. When I solve these two, I get m minus 1. Then L cube t minus 2. Clear? So now there was something connecting these things, okay? There was something connecting these things, but to do any kind of experiment, I have no idea about this thing, okay? Then the first step was to analyze the dimensions of the thing, okay? When we know the dimensions of this one, now we have some pointers about how it's connected with fundamental physical quantities. So I can check, I can try change in mass, length, time, different quantities. I can try to change and try to analyze G, right? See, now I have some kind of understanding about G. So going through this understanding after doing a several set of experiments, they identified that this is a constant. This is a constant with dimensions. This was a constant with dimensions called universal gravitational constant. Clear? Universal gravitational constant. Then they identified that it's common everywhere, wherever you go. Okay, wherever you go, in the sense, it's a different story. We don't need that. I mean, when huge masses are not involved. Okay, why can't we apply Newton's law when there are huge masses involved? Why? Anyone have any idea? Anyone have watched Interstellar at least? Why can't we apply Newton's equations? I mean, when there are huge masses involved. I mean, Newton's equation doesn't work, right? You need Einstein's equation for that. Why? It bends everything, right? It bends light, it bends time, it bends everything, it bends the whole light, like space-time fabric, right? Okay, difference. I mean, it's a huge and nice domain of physics, which I prefer if we had in our syllabus. That's actual physics. But anyways, we still have this stuff. Uh, but I mean, but no doubt, like Newton was the greatest scientist of all time. Okay, there's no doubt about that. Why? There was a lot of, I mean, maths people know differentiation and integration, right? So whatever we do, okay, whatever we do in math, to prove them, we need differentiation and integration. Okay, so the Newton was the guy who invented this differentiation and integration. So whatever the proofs came after that, the Newton was the person who established the mathematical background for everything. So, anyways, we just have to learn this stuff. So like when we know these dimensions of G, okay, when we know the dimensions of G, now we have some pointers to work on this, right? Okay, now I can analyze, right? See, so one of the main use cases of dimensions is we can use dimensions to have some understanding about uh, an unknown quantity. Clear? We can use dimensions to have some understanding about an unknown quantity. Clear? So write this down and try question number 1 of uses of dimensions. Question number 1. And for online students, your tutes have been posted, okay? Your tutes have been posted. You will receive it within like most probably 1 week, okay? So the tutes required for whole 2 months have been posted for online students. You will receive them within 1 or 2 weeks. If you still didn't fill that form, try to fill them today. There's a tute called uses of dimensions. Online students, there's a tute called uses of dimensions. Use that. Use that. If you can't find the tute, just put a message, or else I'll ask to provide the tutes again. I'll upload the tutes again to the Zoom chat. And for online students, especially the YouTube live students, if you need anything, if you need any information, contact this number, 070402 not 70 402 9701. Do question number 1. E equals HF. Tute. You need the tute. Well, tutes. Anyone need tutes? Okay. There are some students who need tutes. Yeah, yeah. E equals HF. Find dimensions of H. Okay. Some students ask some questions from mechanics too. So let's try those questions also. So, so this is also a similar case. E equals HF. E equals HF. So we know that there are different energies. Okay. There are different energies. That means, see this light, it emits some, attention everyone, it emits some optical energy. It emits some optical energy. When I'm speaking, it turns into radio frequency and it moves there. Okay. So I mean, it's another energy. When I'm speaking, it's a sound wave. It's an energy. Okay. And from sun, heat, we receive heat from sun as waves. Okay. So like any energy wave. Okay. any energy wave, okay, they identified that it's energy of a wave, optical wave, maybe sound wave, maybe heat wave, any wave. Its energy depends on its frequency. They identified that, okay. Its energy depends on frequency. For an example, now this transmitter is 783.6 megahertz. So this energy of this sound changes with this frequency, okay. So this energy depends on frequency, okay, to a certain level. But again, after this experiment, the problem they had was there was something connecting these two, okay. There was something connecting these two. So the basic idea is we had to find the other physical quantity who's connecting these two, right. So we put a symbol called h here. We put a symbol called h here. Then we analyze dimensions of both sides. Dimensions of both sides. And whenever you are writing, write these steps, okay. Write these steps, okay. Why each? Just don't go from here to here, okay. In a essay paper, just don't go from here to here. Why? This statement represents something. This statement represents something. What is the meaning of this statement? Meaning of this statement is dimensions of right hand side equals dimensions of left hand side. If two sides to be equal, the dimensions must be equal. Then what is the meaning of this statement? Dimensions of HF equals dimensions of H into dimensions of F. See, each step represents something, okay? Clear? Each step represents something. So in a essay paper, just don't skip the steps, okay? Then I can use dimensions of H equals dimensions of V over F. Then dimensions of E, energy. Energy is ml squared T minus 2. Energy M L squared T minus 2. ml squared T minus 2. Then F, frequency T minus 1. Frequency T minus 1. ml squared T minus 2. I divide it by frequency. Frequency is T minus 1. Then I get this T minus 1 and one of these cancels out. Then after calculations, I get M L squared. L squared. Here I get T minus 1. Clear? L squared T minus 1. Clear? See, now when I know how H is connected with fundamental physical quantities, I have some pointers to do experiments on H. So after the experiments, they identified this H is something called Planck's constant. You have heard the person, right? In chemistry? Yes, right? It was there, right? Yeah. So it was called Planck's constant, can call maybe the father of modern science. Yeah. So that's the idea. Okay, that's the idea. See, so one of the main use cases of dimensions, attention, one of the main use cases of dimensions is you can analyze, I mean, unknowns, okay? You can analyze unknowns. Okay, next one. Next one. Next thing is, okay, quickly write this one if you are still writing. Okay, so now, next one. So there's some kind of, I mean, you have watched Ford versus Ferrari, right? Ford versus, did I ask you this? No. Have you watched Ford versus Ferrari? Anyone? Okay, we have few. Raise your hand. Okay, none. Anyone from this side? Okay, we have one. Okay. Anyways, then again, it's pointless. The example would be pointless. Okay, we can't refer to movies in these classes then. Just let's take this one. So take a vehicle, okay? Why this experimental procedure was there in that movie, but we can forget that. So when you take a vehicle, attention everyone, when you take a vehicle, cross-sectional area of the vehicle, if it is A, that means this is the cross-sectional area that you see of the vehicle when you look at it from front, okay? The air drag, there's definitely a vehicle when it is moving, it feels some air drag, right? I mean, if there is no air drag and friction, okay? If there is no air drag and friction, do we need an engine for a vehicle? No, right? Why? If a system is not disturbed, if there are no external unbalanced forces, it will move forever. Okay? It will move forever. Okay? You don't need anything to move. Okay? If a system is not disturbed, it will move forever. Clear? Ah. So uh, vehicles, we need an engine because of these resistive forces. Okay? There are resistive forces, friction, air drag. So one of the main factors dominating this engine power is air drag. Okay, is air drag. That's why we have very different shapes in vehicles like Ferraris. Okay, to get rid of this air drag and different like components related to air drag. Okay, so anyways, this air drag which is felt by a vehicle, it depends on the area definitely, right? The larger the vehicle, you feel more air drag. And definitely it depends on the density of air, right? Definitely it depends on the density of air. Clear? Mass of the particles, clear? Definitely it depends on the density of air. Then after that, definitely it depends on the velocity, right? Higher the velocity, more air drag you feel, right? Higher the velocity, more air drag you feel. Clear? Ah. So someone suggests that the power of the engine, attention, the power of the engine, okay, power of the engine depends on A rho V cube. A rho V cube. Attention. A rho V cube. Power of the engine depends on A rho V cube. But what is the problem? This can be V. This can be V squared. This can be V cube. We don't know, right? So when we like do some experimental process and come up with an equation, okay, one way to confirm that this equation is correct is using a basic property of dimensions. What is that? The dimensions of two sides must be equal, right? Clear? Dimensions of two sides must be equal. Clear? So check whether this equation is correct or not. Check whether the equation is correct or not. Check whether you have same dimensions in left hand side and right hand side. This is part A. You have this in your that tute second page. After A, try B. First try A, then B. So part A, dimensions of P. Okay, so these are the exact steps. Okay, first take left hand side, dimensions of left hand side. So what are the dimensions of left hand side? Dimensions of power. So we have that ml squared t minus 3. It's given ml squared t minus 3. Then dimensions of right hand side. Dimensions of right hand side. I get dimensions of a rho v cube. Then I get dimensions of a, dimensions of rho, then dimensions of v cube. Then I get what is area? L squared. Area is L squared. Rho density, what is density? ml minus 3. ml minus 3. Then v velocity, velocity lt minus 1. lt minus 1 cube. Velocity lt minus 1 cube. Clear? Clear? Then L squared m L minus 3, ml minus 3, here L cube, here t minus 3. Attention, here L cube, here t minus 3. Then I get L minus 3, L cube cancels out, then I get m, I have m, these two cancels out, then I get m, L squared, t minus 3. See? So left hand side is equal to right hand side, right? So dimensions of left hand side equals dimensions of right hand side. Now tell me, this is the most important part, okay? I mean, you won't get these kind of questions in A levels, okay? These are too easy for A levels, okay? So, but there are some, attention, there are some statement MCQ questions in A levels. Like you have to choose the correct statements, or like you have ABC, you have to choose AB or AC, or you have to choose the correct statements. Okay, if there's a statement like this, these are the things that you have to be really careful. If there's a statement like this, if the dimensions of left hand side of a equation is equal to the dimensions of right hand side of the equation is correct. Is this statement is correct or not? Is this statement correct or not? Dimensions of left hand side of an equation is correct, is equal to the dimensions of right hand side of an equation. Okay? If the dimensions are equal, the equation is correct. Can we consider this statement as correct or not? Yeah, the statement is wrong. Okay, this statement is wrong. Why? Why? We just use that left hand side equals right hand side. So attention, attention. So the idea is, okay, so the idea is you can use this only to prove that an equation is not wrong. You can't tell that the equation is correct. Why? You can't analyze numerical values here, right? That means you get like left hand side equals right hand side. Okay, you prove that you have same dimensions in both sides, but you will get same thing if you have p equals 5a rho v cube. You will get the same thing if you have p equals 10a rho v cube. You will get same thing if you get p equals 100a rho v cube. Clear? Whatever the equation, you would get the same, right? Why? Why? 5, 10, 100, these are numerical values without dimensions. Attention, these are numerical values without dimensions. So you can't analyze the numerical value, right? The correctness of numerical value, you can't analyze it, right? And I mean, if someone asks you, if someone gives you that energy, kinetic energy is mv squared, after dimensional and after analyzing dimensions, you will tell that this is correct. if someone tells you that kinetic energy is E equals mv squared, after analyzing dimensions, you will tell that the statement, this equation is correct. But is it correct? No, right? The actual equation is half mv squared. But through dimensions, you can't analyze this part, right? Why? Half anyways don't have dimensions, right? So you can't tell that an equation is correct. Okay. So after doing this part, what you can do is you can write that the equation is dimensionally correct. You can write this statement, the equation is dimensionally correct. Clear? Only the dimensions are correct, okay? The equation, we don't know whether it's correct or not. You must write that statement, okay? You can't stop it here. You have to write the equation is dimensionally correct. Clear? And the main issue here is like this will be the last day that attention. Uh, the main issue here is this will be the last day that we analyze this thing. That means I will tell you the statement and teach you this concept today. Then for the next 2.5 years, we won't encounter this point again. Why? This is not a very major like or difficult lesson, right? So you won't find this anywhere. But at the A levels, there may be a statement like that, and there's a high tendency that by then you have forgot this point. Okay, okay. So why you have to remember any important point for 2 years, right? Okay. So that's why attention, everyone. You can write this later. That's why I keep emphasizing these points. Why? Whatever you are going to do, you must have a revision plan for A levels. That means what are you going to do the month before A levels? How are you going to revise all the points? So you must start creating this plan now. Why? Assume if someone's going to read the short note, okay, 2 weeks before A levels. So for that you need a short note, right? Okay. So the short note you should start creating it now. If someone's going to read all my notes, you can't read all the notes 1 week before A levels. So, you must maybe choose like 2, 3 colors to highlight. Then you should highlight generally important factors from one color, e- extremely important factors from another. Then in the last 2 weeks, if you have time, you can read everything highlighted. But if you don't have enough time, you can read only the extremely important points. So this is an extremely important point like that. Why? You will most probably forget this point after 2 years. So when you see that statement after 2 years in your A-level paper, you will consider it as correct. See, that's why I'm emphasizing these points. Okay, so for me, it was quite different. I don't like to study. Okay, I never study. So the plan for me was I had a question bank. I had a question bank which I'm going to do 1 month before the exam. So I was just collecting proper questions that can revise the whole syllabus with answers, and I had a question bank. Then my plan was I'm not going to study. If I'm going to sit and study, it's just a waste of time. Okay, anything doesn't go into my brain. So I have a question bank which I'm going to do. Quickly going to write all the answers 1 month before the exam. So for that I had to collect questions and answers, right? So whenever I'm doing a lot of questions, if I find something important, if I find an important question, what I do is I can scan that question. I can scan that question and put it into a common PDF where I collect everything. Okay. Then by the exam, I had a question bank of important questions which I'm going to do 1 month before the exam. Okay. So whatever your final plan for A levels should start now. Okay. Should start now. Okay. So maybe choose 2, 3 colors, color pens, and underline, and you must have the same convention for 2 years. This color means most important facts. If I'm out of time, if I have very less time remaining, okay, then I'm going to read only these color points. See, you must have some kind of a convention which are going to continue for 2 years. Okay, so just start doing stuff now. Okay, so that's why I'm emphasizing these facts. Then you have to know, okay, this is important. Then use whatever the convention you use. Put it into a short note if you are a person who works with short notes. Or if you are underlining, choose the proper color and underline. If you are highlighting, choose the proper color and highlight. If you just collect a question bank, uh, put this question into your question bank with proper answers. There, in that answer, write this is dimensionally correct and underline the point dimensionally. Then you will remember the point. See? So whatever the plan you are going to, I mean, I'm just making your life easy, okay? Why? In the last 2-3 months, students struggle a lot, okay? They don't have proper notes, they don't have proper question bank, they don't know what to do. We get thousands of calls about what to do, what can I do in the last 2 months. I just don't like answering those questions. Of course, why? It's pointless. How can you help in the last 2 months when a student don't have a plan for 2 years, okay? What you were not able to do for 2 years, how can I help you to do that in last 2 months, right? So it's pointless, right? So I'm just saving your lives, okay? This process, if you do it properly, will make your life really easy in the last 2 months, okay? So whatever you do in the last 2 months for A levels, start planning now for all subjects, okay? Ah. Okay, next one. Part B. S equals ut plus half at square. S equals ut plus half at square. Quickly get values. Others finish the A, B, C, D questions. Quickly get the answer and others finish A, B, C, D. All. S equals ut plus half at square. So for this equation to be correct, dimensions of S. What is the dimension of S? L, right? What is the dimension of ut? Dimension of ut is dimension of u, dimension of t. What is the dimension of u? They have given that velocity Lt minus 1. Lt minus 1. Dimension of u, it's Lt minus 1. Dimension of t, it's t. It's t. Dimension of u, Lt minus 1. Dimension of t, it's t. Clear? Attention. I mean, attention in the sense you don't have to pay attention if you, I mean, if you understand, you can just do whatever you are doing. You can continue the questions, okay? You can continue the workbook, but just don't speak, okay? Why? There are some students who are paying attention, so I need absolute silence when I'm explaining. But I mean, if this question was too easy, just do whatever you are doing, okay? Just keep doing the workbook, do something, okay? So u, Lt minus 1, t, here it's t, then I again get L, I again get L, then half at squared, half at squared equals dimensions of half. You have to break this into parts, okay, first. Then t squared, then half, no dimensions, half, no dimensions, a, acceleration Lt minus 2, acceleration Lt minus 2, dimensions of acceleration Lt minus 2, dimensions of t, capital T, t squared, clear? Then t minus 2 and t squared cancels out. T minus 2 and t squared cancels out. Then I get L. Then I can tell dimensions of S equals dimensions of ut equals dimensions of half at squared. Then you can write that the equation is dimensionally correct. Clear? Then you can write the equation is dimensionally correct. So if you quickly finish all these, try to finish the mechanics tute. Okay. Anyone who need the mechanics tute? Anyone who need the mechanics tute? Okay, there are some students. Okay. Okay. If you have time, try to finish the mechanics tute also. Write this down. Then let's move to the next use case. Okay, attention. Next use case. Next use case. Attention, everyone. Next use case. Um, we call this, anyone write in this? Anyone? Quickly try to finish. Quickly write this down. Others can try to prove the third point, deriving an equation using dimensional analysis. And I mean, if you are new to the class, if you haven't watched the recordings, if you have missed initial parts, basic concepts of dimensions, just wait after the class. And for online students, you can contact this number and join the WhatsApp groups. And for physical class students, just give your numbers today after the class and we'll add you to WhatsApp groups. Then we'll provide the recordings again in the group. So if you have missed anything, we'll provide the recordings again in the group. So just try to watch the recordings if possible. Okay, attention. So this is the idea. Um, Third use case. What was the first type of clock that was invented? What was the first type of clock that was invented? Um, it was like something like this, right? Attention, everyone. Pay attention. If there's a pin here, if there's a pin here, if you have values around, if you have values around, sun shines from some one side, then the shadow will show the time, right? Then the shadow will show the time. Clear? Sun shines from one side, then the shadow will show me the time. Clear? So this was the first type of clock. Okay. Anyways, not significant. But what was the first mechanical clock? What was the concept behind first mechanical clock? A pendulum, right? A pendulum. Okay, concept behind the first mechanical clock is pendulum. That means, have you seen this? There's a pendulum moving like this. There's a pendulum moving like this in a mechanical clock. Why? What is the case? I mean, for any clock, they need a reference to time, right? They need a reference to time. Okay. So if the periodic time of this pendulum is 1 second, then my clock knows what is 1 second, right? See? So the pendulum is used to create a reference, okay? Pendulum was used to create a reference to what is 1 second, okay? So to analyze this, to understand this properly, okay? I mean, somehow I have to make the periodic time of this pendulum. Periodic time means it goes like this and returns to the same place. I have to make sure that the periodic time of this pendulum is 1 second. Then we can use this to create a clock or something like that. Clear? So the basic requirement here is to do a proper analysis and find an equation for this motion. Still, I don't have an equation for this motion. I don't know who's dominating this motion. Okay, clear? I don't know who's dominating this motion, whether it's the mass of the pendulum, whether it's the length, I don't know. So I don't have enough knowledge to make sure that the periodic time of this one is 1 second. Clear? But I can assume. I can assume. That means I can assume that the periodic time of this pendulum, I can assume that it depends definitely on this length, right? When this length changes, I can assume that when the length changes, it will change the periodic time of this clock or the pendulum. Clear? Then I can assume that the periodic time depends on the mass. Clear? I can assume that the periodic time depends on this mass. Then again I can assume that, what else? The periodic time depends on gravitational acceleration. I can assume that. Why? Who's gonna pull this backward again into the initial position? Gravity, right? When I move it like this, it will not return if there's no gravity, right? So gravity is the thing who pushes it back to the initial state, right? It goes up, returns due to gravity. Goes up, returns due to gravity. So I can assume that this time, periodic time, depends on length, depends on mass, depends on gravitational acceleration. Clear? I can come up with with several assumptions. Okay, okay. Only assumptions. I have no idea. Still, I don't have any idea about what is happening. Clear? And at the same time, it may be L, it may be L squared, it may be L cube. I don't know exactly, right? Why initially in some equations we had A rho V cube. See, I don't know whether it's L, L squared, L cube, what. Okay, so I can assume that it's L to the power X. M, I don't know whether it's M, M squared, M cube. No, right? So I'll just put Y. G, G cube, I don't know, right? So I'll just put it as is it. So that means time, the periodic time depends on some kind of a power of length. Okay. The periodic time depends on some kind of a power of the mass. The periodic time depends on some kind of a power of the gravitational acceleration. Still, I don't know. All are assumptions, right? All are assumptions. Clear? So still I don't have enough information, but now I know that from my assumptions, purely by my assumptions, without any experiment, purely by my assumptions, I know that T depends on L to the power X, M to the power Y, G to the power Z. How can you remove an proportionality constant? How can you remove a proportionality constant? Using a, how can you remove a proportionality, using a proportionality constant, right? You know that? That means y proportional to x means what? Y proportional to x means with x, y increase, right? With x, y increase. This is the meaning of proportionality, right? Clear? Two quantities are proportional means y increase with x. But it can be y equals 2x. It can be y equals 5x. It can be y equals 100x. I don't know. In all these scenarios, y is proportional to x, right? Clear? Y is proportional. This is the symbol that we use for proportionality, right? You know that, right, from O levels? Yeah. This is the symbol that we use to show a proportionality. Proportionality means with y increases with x, but it can be y equals 2x, it can be y equals 5x, it can be y equals 100x. There's some kind of a numerical value connecting a proportionality, right? Clear? So proportional means y equals some kind of a numerical value into x. So here also I can put a numerical value here. I'll use k. So I can tell that here it's I can put a value called k, and I can write k is a dimensionless constant, just a constant, some kind of a numerical value. So any proportionality is connected by by some kind of a numerical value. Clear? Clear? It can be k can be 2, 5, 100,000, million, anything. Okay. So I still don't know a lot about this equation or the behavior of this pendulum. Okay. I still don't know a lot, but I know one thing. If this equation is correct, dimensions of left hand side, the dimensions of left hand side must be equal to the dimensions of right hand side, right? I know one thing, the dimensions of left hand side must be equal to the dimensions of right hand side, right? It's confirmed. That's all I know. Clear? So I'll do what I know. Okay. Dimensions of t equals dimensions of k, lx, my, gz. Then what is the, I can break this into parts. T, I can break this into parts. K, dimensions of L to the power x, dimensions of M to the power y, dimensions of G to the power Z. Then what is the dimension of T? Time. Capital T, right? T is time. Dimension of T is capital T. I know that. What is the dimension of K? Nothing, right? K is a constant. K is just a numerical value, right? So K is just a numerical value. Clear? It's dimensionless. Clear? So there's nothing here. I can put 1. What is the dimension of L? It's a length. That means capital L, right? Capital L. Dimension of length is capital L. Clear? So it's L to the power x. Clear? Then what is the dimension of M? It's a mass. That means capital M, right? Dimension of mass is capital M to the power y. G, what is G? Gravitational what? Gravitational acceleration. It's an acceleration, right? G is an acceleration. So it's LT minus 2, right? Dimensions of acceleration is LT minus 2, right? To the power Z. Clear? Clear up to this point? Clear, everyone? Yeah. Now what can I do? Here it's L to the power x. Here it's M to the power y. Here it's L to the power Z. Then T to the power minus 2 Z, right? When I expand this, it's L to the power Z. T to the power minus 2 Z. Clear? Then L to the power x and Z, I can write L to the power x plus Z, right? Why? L to the power 2 into L to the power 3 means L to the power 5, right? 2 plus 3. See? Then L to the power x plus Z. Then M to the power y. M to the power y. L to the power x plus Z. M to the power y. T to the power minus 2Z. Clear? Now there's something really nice about these dimensions. These dimensions are fundamental physical quantities which does not depend on anything else. That means, okay, I can write it like this. I have t here. T means t to the power 1, right? T means t to the power 1. Clear? I don't have m here, right? I don't have m in this side, right? That means it's m to the power 0, right? Clear? I don't have L in this side. Clear? I don't have L in this side. That means it's L to the power 0. Clear? So T means L to the power 0, M to the power 0, T to the power 1. Clear? Then in this side, it's L to the power x plus z, M to the power y, T to the power minus 2z. So what is nice about these dimensions is this T can be created only by this T. That means I can't multiply L and M and get T. I can't multiply M and T and get L M. No, right? Why? These are fundamental physical quantities. Clear? What is the meaning of a fundamental physical quantity? It can be derived by other physical quantities. It is just, I mean, it's unique, okay? Okay, time, I can only measure time. I can't measure length and get mass and do something and get time. No. So these are direct physical quantities. Clear? That's why we call them fundamental physical quantities. So due to this behavior, this L can be created only by this L. This M can be created only by this M. This T can be created only by this T. That means for this, since this side is L to the power 0, by comparing the power of L, by comparing the power of L, this 0 must be equal to x plus z, right? Clear? Clear? Why? This L can be created only by this L, and two sides must be equal. Two sides must be equal. So here it's L to the power 0. Here it's L to the power x plus z. Then 0 equals x plus z, right? Then M. M. Here it's 0. Here it's 0. Here it's y. Then T. Here it's 1. Here it's minus 2z. Then I get, by solving this, I get z equals minus half, right? By solving this, I get z equals minus half. Then here y equals 0. Here y equals 0. Then here x equals minus z. X equals minus z. That means minus z means minus half. That means minus half means half. Clear? Half. Ah. So now I know x, y, z. What is x, y, z? Now I can write this equation. T equals k L to the power x. What is x? Half. M to the power y. What is y? 0. G to the power z. What is z? Minus half. That means k L to the power half. M to the power 0 means 1, right? M to the power 0 is 1. G to the power minus half, I can take it here. Then I can write k. This is root L. This is root G. Root G. Then I can write k root L over G. Then T equals k root L over G. I started with nothing. Okay. I started with nothing. I didn't know whether M affects T. I didn't know whether L affects T. I didn't know whether G affects T. I didn't know which power of L of xt. I didn't know which power of M of xt. I had no idea. Clear? I had no idea, but now I have an equation. Okay, I have an equation on how T is affected by all other physical quantities. That means I have an exact equation for the periodic time. Clear? Clear? So I started with nothing, without any idea, and I know that now M have no impact here. That means I can change the mass of the pendulum, it won't affect. Clear? I started with nothing, but now I know there's some kind of a constant, attention, there's some kind of a constant and root L over G. Now I know the exact equation. Clear? Now I know the exact equation which is dominating this periodic time. Clear? Then after that, I mean, this is the limit, attention, okay? This is the limit of periodic time. This is the limit of dimensional analysis, okay? I can never find K, okay? I can never find K using dimensional analysis. Why? K is what? A dimensionless constant. Can you remember? So this is the limit of dimensional analysis. Why? After this point, I can't analyze K, right? Why? K is dimensionless. If something is dimensionless, dimensional analysis doesn't work for that, right? But now I can do an experiment. Why? Now I can choose a length that I know. I can choose 1 meter. G I already know. Then I can measure T, or I can get some kind of a known T. Then if I know T, L and G, I can calculate K. So I can do a small experiment. I can do a small experiment and find that experimentally K equals 2 pi. So my exact equation is 2 pi root L over G. This is the equation for the periodic time of a pendulum. Clear? So I started with nothing, okay, without any information, without just a set of assumptions, okay. Attention, everyone. I started with just a set of assumptions, but I come up with an equation, an exact equation on the how the periodic time of the pendulum depends on other stuff, okay. So those days, okay, we had very limited amount of experimental procedures or technology. Okay, one of the main methods of deriving equations was dimensional analysis. Okay, why? It's one fundamental thing. Okay, even Einstein's equation is wrong if it is not dimensionally correct, right? So it's one fundamental thing about physics. So they used this a lot to prove a lot of equations. Clear? Clear? So write this down and just let me know if you have any questions. But please, okay, write it up to this point. Then write experimentally k equals 2 pi. Why? Attention. This is not a part of dimensional analysis, okay? You can't find k. It's an experimental procedure after that. So write experimentally k equals 2 pi, then t equals 2 pi root L over g. Here when you introduce k, attention, when you introduce something to an equation, you have to describe that in physics. So when you are writing k here, write k is a dimensionless constant. Clear? Write that statement, okay? Write the statement called k is a dimensionless constant. Write this down. Then write this down and try second question. Question B of that tute. Try question B of that tute. This is A. So for online students, the mechanics tute and the workbook and everything is available. For physical class students, if you don't have the workbook or mechanics tute or anything like that, just inform, okay? Will be distributed now. All the tutes will be distributed now. If you have any questions, please ask. And then part B, yeah, only the students who didn't get the workbook. Raise your hand. Okay, only the students who didn't get the workbook, raise your hand. Try question number B. Try question B. Speed of V, speed V of a transverse wave traveling along a stretched string depends on the tension, length, mass of string. Derive an expression for V. Properly understand this, then try B. And attention everyone, attention. Velocity you know, tension, T is a force, okay? You know that, right? Tension, T is a force. Tension, T is a force. Try question B. Try question B. And some students ask these questions, so I'll explain these questions. So whenever you have time, you can try these questions too. Mechanics tute. I think I asked you to try this question before. Mechanics tute. Mechanics tute. Question number 23. Some students ask question number 23. And some students ask question number 22. You can try question number 23 and question number 22. Attention, please be silent. Mechanics question number 23 and question number 22. So whenever you have time, try these questions. Some students ask these questions, so I'll explain those questions too. For now, try question number B. Properly understand this, slow and steady. Then try question B for dimensional analysis. Some students ask for question number 27 also. Didn't we discuss question number 27, mechanics tube? Attention. Didn't we discuss? We discussed, right? These two we didn't, right? Okay. Try these two. We have the answers for this. So you have enough questions to do, and I'll give enough time, okay? Because it takes time for some students to understand this. So just try to do question number B along, okay? If I discuss question B quickly, then you won't understand. So just take your time and try question number B. Try to get a proper answer for question number B, question B. Then if you have time, if you are done with that question, some students will quickly finish this. Then others try mechanics tute, question number 23 and 22. Then you can take your main tute. Main tute, units and dimensions tute, theory tute. In that tute, you have some more dimensional analysis questions in exercise 4. You can try exercise 4, question number 4 and 5. Exercise 4, question number 4 and 5. So the plan is you have a tute to fill in the blanks. Try question number B of that tute. Then mechanics, question number 23 and 22. Then exercise 4 of your theory tute. Theory tute, units and dimensions, theory tute. Exercise 4, question number 4 and 5. That means your question book, the theory book, not workbook. And whenever you have time, try to finish the workbook, okay? Okay. And anyways, from next week onwards, the Sunday class students and Thursday class students will get two papers, okay? Two different papers. Otherwise, this paper, model paper 2, is already released on Thursday. So, I mean, it's a problem. So, from next week onwards, Thursday class students and Sunday class students will get two different papers. Otherwise, we release it on Thursday. Then, if it is the same paper, you can always see the paper before the class. Try question number B. Then mechanics tute, question number 23 and 22. Then in your theory tute, units and dimension theory tute, exercise 4, question number 4 and 5. Question? Okay. I'll discuss question number B. Question B. Uh, uh, what they mention is speed of a, I mean, now it's just executing the same set of steps, okay? Nothing new, just executing the same series of steps. Speed of a attention, speed of a transverse wave depends on, it depends on the tension, length, mass. So V depends on tension, T to the power something, tension. Then here I'll take tension as, okay, they have given T to the power X. It depends on L, length, L to the power Y. Then mass, M to the power Z. Then I can put a proportionality constant, dimensionless constant, V equals K, T to the power X, L to the power Y, M to the power Z. Then I can analyze dimensions of two sides. Dimensions of V equals dimensions of K, T to the power X, L to the power Y, M to the power Z. Then I can analyze them separately. V, K, T to the power X, L to the power Y, M to the power Z. Clear? Clear? Then what is the dimension of V? Attention everyone. What is the dimension of V? L t minus 1 velocity. K is attention. K is dimensionless. K is dimensionless. T is tension, right? T is tension. Tension is a force. We initially got the dimension of a force, right? What is the dimension of a force? K is dimensionless. Here, M, LT minus 2, right? Attention, I need silence. K is dimensionless. T is a force. Force I can take using F equals ma. M is mass, acceleration LT minus 2, clear? Or else we have in the previous page, we have dimensions of force. So L is a length, L is a length, M is a mass, L is a length, capital L, M is a mass, capital M to the power Z. Clear? So this is the dimensional representation. Clear? Velocity Lt minus 1, k dimensionless. Tension is a force m Lt minus 2, sorry, to the power x. L to the power y, L is a length, m is a mass. Then I get Lt minus 1 equals here m to the power x, L to the power x, t to the power minus 2x. Then here L to the power y, here m to the power z. Then I can add these physical quantities m to the power x plus z, m to the power x plus z, L to the power x plus y, L to the power x plus y, t to the power minus 2x. So in this side I have m to the power 0. I don't have m here. So m to the power 0. L to the power 1. T to the power minus 1. So I can compare the powers. Then I get m to the power 0 equals m x plus z. Then L to the power 1 equals here x plus y, here x plus y. Then here t minus 1, t minus 1, t to the power minus 1, here minus 2x. So I can solve this. Minus 1 equals minus 2x, then x equals half. X equals half. Minus 1 equals minus 2x, then x equals half. If x equals half, y equals 1 minus x. That means 1 minus half, again half. Then z equals minus x. Z equals, I take x here, then minus x. Minus x means minus half. So I get uh, v equals k, v equals k, t to the power x, t to the power x. What is x? Half. L to the power y. What is y? Again half. Then m to the power z. M to the power z. What is z? Z is minus x. That means minus half. Then I get k t to the power half. Here L half. Here m minus half. I take it down. Then I get something like this. So this means k, here it's root t, here it's root L, here it's root m. Then I get t equals k root t L over m. T equals root k root TL over m. Clear? Ah. So I'll give you the interval now, right? So and please let us know, okay, if it is too cold or anything like that. We usually put all the ACs to 19. Okay, so if it is too cold or anything like that, just let us know. So you can After the interval, you can try these questions. Mechanics tute, question number. Mechanics tute, question number 22, 23. Yeah, question number 22 and 23. Then theory tute, units and dimensions theory tute. That means theory book, theory book. This one, this theory book. Exercise 4, exercise 4, question number 4 and 5. Question number 4 and 5. So the time is 5 past 5. I'll start around 5:25. Quickly try to get the interval and start doing these questions. Yeah, we'll provide mechanics tutes again. We'll provide tutes in the Zoom chat again. And if there's any online student who need tutes or anything like that, contact this number. Online students, if you need any assistance, if you can't any tute, contact this number. Put a WhatsApp message. Oh, So I have given time to try these questions, okay? Try the questions, okay? Try to finish at least one or two questions. I mean, for mechanics questions, if possible, at least try to draw the diagram. If it is difficult to finish the question, if it is difficult to get the answer, at least try to draw the diagram. Likewise, try to do something, okay? Anyone else having issues with AC? What about this area? Too cold? No, 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 perfect. Then what about others? Anyone having issues with the AC? Okay. Okay. Attention. Question number 22. Question number 22. It's just about definitions. Attention, everyone. Attention. It's only about definition. Question number 22. They are asking, I still hear people talking. Find the mean force exerted on the hemispherical path by the object. Okay. They are just asking the mean force, right? Question number 22. Only attention, everyone. Please stop talking. Question number 22. Sorry, question number 22. They are asking the force. So, I mean, these questions are not, I mean, actually, you will understand these questions properly when we do mechanics, okay? I'm just giving these questions so that you can play around with your O-level knowledge and you can see, like, what is after your O-level knowledge, okay? Because from your O-level knowledge, what you have done is, like, given the set of data, when they give u and t, you find s by s equals ut. Nothing after that, okay? But here, there's a lot you can do from that knowledge, okay? There's a lot of areas you can apply those knowledge. So the mechanics tute is there so that you can understand that there's a lot of things that you can do with your existing knowledge, okay? Then you know how to apply your existing knowledge in different scenarios. It helps you understand physics better, okay? Then when we move into mechanics, you will feel mechanics easy, okay? That is the basic idea. Why? When we grow this mentality, the way of thinking for a longer period of time, then all of a sudden when we move into mechanics, it's not like magic. Okay, these questions are difficult. Now it's not like that. Okay, I mean, from the first day you found like, okay, the thing is difficult, so I have to do something. Okay, so it's good to know things like as soon as possible. Okay, it's good to know things as soon as possible. So if we can, I mean, so I mean, it's not necessary for you to be able to get answers for these questions. These are anyways difficult, really difficult. Okay, what I need you to do is just play around with your knowledge, existing knowledge, so that you can like come up with some kind of answer, so that you just try to apply your knowledge in difficult scenarios. That attitude matters when we move into mechanics. Why? If you take 10 questions, you will be able to do 2 questions easily. 4 questions with a little bit of struggle when we move into mechanics. 4 questions with a little bit of struggle. Then there will be 2, 3 questions like you may have to try for 2, 3 weeks to get the answer. But the most important questions are those 2, 3 questions. Why? I mean, those are the questions that acts as an exercise for your brain. Okay, so that only those two questions which you are unable to do, those two questions are the questions that are going to help you in this process of being an engineer or a doctor. That means a person with a higher thinking capacity. Okay, okay. So the difficult questions, the questions which you are not able to do, those are the most important questions. Why? That's what you help you to go from like where you are today to a person with a higher thinking capacity. Okay, so basically engineer or doctor or a physicist or anyone is just a person with higher thinking capacity. Okay, so question number 22, it's about definition. Definition means what is the only equation you know from all levels to find force? F equals ma. F equals ma. Okay, you know this, right? What is the what is the definition for acceleration? What is the definition for acceleration? Delta V over delta t, right? Delta V over delta t. Velocity difference over time difference, right? Clear? So when someone asks you the mean force, okay, when someone you ask you the mean force, what you have to do is mass into mean velocity difference over time, right? Mass into velocity difference over time. So it's like this. You start here. You start here, okay? You start here. Velocity is v. Velocity is v. Clear? The velocity is v. Now, first thing, it's just a set of series of steps. First step is to find the difference in velocity. Velocity difference. So, always, what is difference? Difference means final value minus initial value, right? In any scenario, difference means final value minus initial value, right? So now try to understand. I'll choose this as my positive direction. What is the final velocity? V. Downwards. Clear? V. Minus, what is the initial velocity? Is it V or minus V? It must be minus V. Why? We haven't worked with vectors like this in O levels, but now we should understand vector is what? Something with a direction, right? Vector is something with a direction, right? Velocities, they have directions. So, if this is positive V, this is negative V, right? Why? It's in opposite direction. Clear? 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 Everyone? So, it's minus V. Okay, so it's 2V. If someone moves like this and now he is moving like this, that doesn't mean the velocity didn't change. Velocity was initially like this. Now it's like this. Entirely different velocity, right? Entirely different velocity. Why? Although the magnitude is same, the direction is opposite. Clear? Direction is opposite. So now we have to have a higher understanding about vectors. Okay, a better understanding about vectors. Vectors have directions, right? Clear? Vectors have directions. Clear? So this v and this v is not the same. Clear? Final velocity is v. Initial velocity is minus v, right? Clear? Clear? Initial velocity is minus v. Clear? Clear, everyone? Got the idea? So the actual velocity difference is 2 into v. Is that clear? Clear, everyone? Clear? So this is velocity difference. Now I have to find the time taken for this process. How can I find the time taken for this process? What is this length? Do we have the radius? Yes. What is this length? Pi r, right? This length is pi r, right? Not 2 pi r. Half of it means pi r. Clear? This length is pi r. Clear? So it's pi r. What is the speed? V, right? It's continuously moving with the speed. Clear? Clear? The length of the path is pi r and it's moving with a speed or velocity of v, right? So distance over velocity, you get time, right? Clear? Distance over speed, you get time, right? Why? Speed equals distance over time. So time equals distance over speed, right? Clear? So distance is pi r, not 2 pi r, it's not a full circle, over speed or velocity. Clear? Is that clear, everyone? So now I have the velocity difference. Now I have the time. If I know the change in velocity and time, I know acceleration. Clear? So now it's F equals m. Velocity difference is 2v. Velocity difference is 2v. Change in velocity is 2v. Time taken for this process is pi r over v. Time taken for this process is pi r over v. Clear? So I get m 2v squared. V comes here. V comes here. Then 2v squared over pi r. Clear? M 2v squared over pi r. Clear, everyone? Clear? So this is mean force. Mean force. So it's just going for the initial definition. What is the initial definition for force? Mass into velocity difference over time. Thank you. Mass into velocity difference over time, right? Clear? So it's just using the basic definition again. Okay, see? We already knew the definition, right? But this is an entirely different application. Okay, so these days what we are training to do is things we already know, but different views of it. Okay, that's what we are trying to do. Try question number 23. And I mean, these days I got a lot of messages about whether to choose between chemistry or IT, or sometimes like maybe science or commerce. What should they do? I mean, it entirely depends on like what you like. Okay, it entirely depends on what you like. But I mean, just don't take the decisions based on limited knowledge. Okay, I mean, attention. I mean, attention in the sense you don't have to think about this thing if you are already, chosen whatever you are going to do. But just please listen, because it's entirely based on what you like. Okay, but the problem is sometimes what you like depends on limited information. Okay, what you like depends on limited information. That means the fact that you like to work with the computer doesn't mean you will be good at IT. Okay, it's a whole different scenario. You have to you may like to play a game for 2-3 hours, but when it is 16-18 hours per day, when the deadline is close to provide a project, it is not colored, it's programmed, so all letters. And you have to think mathematically, so you have to train your brain to work for maybe extended periods of time. Then you will start hating IT. See, so sometimes you take decisions, you think that you like that based on limited information. So just talk with professionals. Okay, if you really like IT, talk with professionals and ask what are the things like good stuff and bad stuff about doing IT. Okay. Just for me, even me also after I'm anyways a business guy. Okay, I'm anyways a business guy. That means I was always planning to do business. Okay. So even after A levels, I quickly went to start doing SIMA. Okay. But even me and my father both understood that SIMA is going to be useless because every day my father drops me off at Wisdom, that SIMA Academy, and like in the evening pick me from one goal face every day. Okay, so after few like 5-6 days, he didn't even called and check me where I am. Just he like I just go to Wisdom, and after like 1 hour I'm at one goal face. So he at the evening, without even calling, he puts the vehicle to the one goal face car park and call me. I'm at one goal face. Come when you're done. So so didn't learn anything from there. so so But anyways, I still like to do business. I anyways like to do business, but even there, what I understood was it matters. Doing SIMA matters. Why? It's not the knowledge. I didn't get any knowledge because I was not there to learn. Uh, so, but the people matters. Why? Those the people, that kind of people, they anyways don't like to learn and stay at a lecture hall. Okay, so all of us, like there were like 30 50 students like me. We all, I mean, we stay for the first lecture 1.5 hours, then we are going to one goal phase to have some fun. That's what we are going to do the whole day. But these are the kind of people who see a shop and see and think, okay, if we do what the hell these people are doing, if we change this logo to this one, and if we change this business model, it will work. These are the kind of people with that mentality. Yes, they don't care about learning, but their mind works. I mean, even today, whenever I'm doing different businesses, working on different projects, I contact them. Why? Their mentality matters. Okay, so the fact that they don't like to stay at a lecture hall and learn commerce doesn't mean they are not good at business. No, they were great at business. They are the kind of people who just go around enjoying one golf face, but whenever they see a shop who's doing the business not in the correct way, they are the kind of people who go to the counter and ask for the owner's phone number and call him and inform that, like, whatever you are doing, it's not correct. So these are, I mean, really straightforward people, really straightforward people. So these are the kind of people who are good at business. Now they are, I mean, everyone is running a great business. Everyone, as I know, I mean, we have a group. We stay in contact. Everyone is running. So see that, I mean, sometimes it's their passion. It's their passion. It's something they feel always. What is good business? What is bad business? What is the correct way of doing a business? What is a great logo? What is a, so, like, so they was want to do that. Okay, so for me the problem was, what I figured out was, whenever we are trying to do business, we get limited with due to the reason of limited knowledge. So if I go to University of Moratuwa, I mean, I was already sure that I was going to get 3 years. Okay, it was quite obvious because I inherited a huge brain from my father. No credits for me. Okay, so anyways, I was going to get 3 years. So my plan was, if I go to University of Morocco and learn a lot of electronics, it will open up more opportunities, right? It will open up more opportunities. Now we are working with different US companies. Maybe we recently got a project from California like that. So it's due to electronics knowledge and software knowledge. So for me, I was eager to learn more so that I can do business in a huge area. So still my main focus is on business, but that doesn't mean I have to skip University of Moratuwa and do only business. No, if I go to University of Moratuwa, it will expand my range of doing business. See, so sometimes, yes, you may like commerce. Okay, so you may prefer to do commerce, but at the end of the day, if you are planning to create a huge business, maybe the best option would be science. Why? You may be able to work with tech people. Okay, then it will open up new opportunities. So it entirely depends on you, but just the fact that you like to do business doesn't mean you have to do commerce. See, so you have to you can't take the decision based on limited knowledge you have. Okay, I'm just talking for the people who are like trying to get a better decision. So just the fact that you like to do business doesn't mean you have to do commerce. No, I think for a person who likes to do business, the best option is science. Why? It opens up a lot of opportunities, huge opportunities. Okay, so it depends. Okay, I can't think for you. Okay, I can't think for yourself, but just if you have to take this decision, talk with lot of professionals. Okay, talk with a lot of professionals, talk with business owners and ask what should I do. Then they would recommend some stuff like that. Just collect a lot of information and take the decision. Question number 23. Okay, attention everyone. Okay. So, and at the same time, like if you already own a business, the running that business, it removes all the joy of building a business. Okay. Same happens for me with education. I mean, my parents own none of my, anyone don't care if I get selected for University of Moratuwa. Whether I mean, for the first and second prize givings, my parents were there. After that, for the next three prize givings, they didn't come. After that, that last two prize givings, even I didn't go there. So why with my background, uh, it's quite obvious. It was quite obvious. So being good at science, being good at physics, I mean, nobody cares at my home. Okay, nobody cares. Okay, you were the class first. Okay, so that's all. Nobody cares. But I'm not from a business background, so my father's an engineer. My father is an engineer, so it's a different story. So me building a business, I enjoy that process. Why I had to do that from scratch. So inheriting your father's or mother's business and doing that will remove that fun out of it. Okay. So try to build something of your own. That's fun. That's fun. So for me, being selected to University of Moratuwa, no one celebrated. Okay. Even I didn't wake up at night to check my results. Okay. So it's nothing for my family. Okay. They don't even care. But me being able to build something from scratch, it's something new for me. So that's what I enjoy. I don't enjoy being able to understanding physics. I don't enjoy that, but I really enjoy teaching. Okay. That's one thing that I never gonna stop, because even from you know when I was doing A levels also I was teaching. So something that I really like is teaching. But other than that, understanding physics, I don't enjoy that, because I anyways understand stuff. So being able to do something that is difficult for you, it's really fun. Okay. It's really fun. So try to build something of your own. Okay. So if you are not from a very educated background, or like it's great. Okay. If there's no one to help you, then it's great. Why? Then you have to build everything from scratch. So then when you get selected to maybe University of Moratuwa, maybe MIT somewhere, then the whole credit goes to you, right? So just try to build something of your own. Okay. That is the basic idea. Okay. So this height is A, radius is R. This height is A, radius is R. I explained this for some students, so them they can try other questions. Try to finish the whole tute. Some students have only one or two questions remaining, I think. Try to finish those questions. Okay, it doesn't matter. Sometimes to finish those two questions, it may take 2-3 months for you guys. Okay, it doesn't matter. Okay, just try. Just try. Uh, so this is the idea. Attention, everyone. Stop speaking. Okay, I need silence. You have the weight of this object mg. You have the weight of this object mg. uh, Now this is a question related to moment. Okay, this is a question related to moment. Why? For this wheel to climb this step, okay, for this wheel to climb this step, it should rotate around this point, right? For this wheel to climb this step, it should rotate around this point, right? So for something to rotate, what do we need? For a moment. Can you remember? A door rotates when you provide a moment. Can you remember from our level knowledge? So this is all about moment. This weight, it's creating a moment in this side, this direction, right? See, due to this weight, it tries to rotate in this direction. That's why I can't go up. Clear? That's why I can't go up. Clear? So what is the moment? And whenever it's rolling up, it rotates around this point, right? Attention. Whenever it's rolling up, it's going to rotate around this point, right? Clear? So what is the moment created by weight around this point? I have to rotate the system around this point to climb this step, right? Clear? What is the moment created by weight around this point? If this length is B, if this length is B, it's mg into B, right? Why? What is the definition of moment? I'll take it as L1. What is the definition of moment? Force into perpendicular distance, right? So force is mg, perpendicular distance B, right? Clear? Force is mg, perpendicular distance B. Clear? It's mg into B. mg into B. Clear? Now I have to provide the moment in opposite direction to climb this step, right? So if I put a force like this, what is the moment provided by me here? If this length is h, if this length is h, the moment created by me is F into h, right? Force is F, clear? Force is F. Perpendicular distance from this point is h, clear? Force is F. Perpendicular distance from this point is h, clear? So it's FH. FH, clear? Force into perpendicular distance, FH, clear? So when this opposite moment is equal to the moment provided by me, then this will climb, right? Okay, it will rotate around this point, clear? That means when L1 mgb is equal to my opposite moment fh, then I can climb this step, right? Is that clear? I mean, this weight is holding this wheel, right? Why? There's a moment in this direction. If I provide an opposite moment, clear? If I provide an opposite moment, it can rotate around this point and climb this step, right? Is that clear? Is that clear, everyone? So this is the target. So the force that I should provide is mgb over h, clear? mgb over h, but they are asking for the minimum required force, right? They are asking for the minimum required force. So now you should understand, higher the h, lower the f, right? See, higher the h, lower the f. Is that clear? Higher the h, lower the f. Clear? So, I mean, if I can make this distance higher, I can use a small force, right? Clear? Why? Higher the distance, smaller the force. Clear? But can I apply the force here to make h higher? No, right? I mean, there's no point of applying the force here, right? So anyways, my force should be connected with this wheel, right? Somewhere. Clear? So my target should be, my force should be applied on the wheel, but from a maximum distance. Is that clear? So where can I find that maximum distance? What is the maximum gap that you find in a wheel? 2r, right? Diameter. What is the maximum distance in a wheel? Diameter, right? So I'll try to find the diameter from this point. Now, from here to here, it's 2r, and this is the furthest point from this point, right? Clear? Clear? So the maximum distance I can have from this point is 2r, right? And this is the point. Clear? So if I can apply the force here, if I can apply the force here, clear? Then h becomes 2R, right? Why? Then my moment becomes L2 becomes force. I'm applying the force in a way that it's perpendicular. Force into 2R, right? Force into 2R, clear? Force into 2R, clear? 2R, clear? Ah, so that is the maximum distance I can have from this point, right? I mean, when you try to open a door, you find the maximum distance from the hinge, right? You don't try to, if the door is like this, you don't try to open the door like this, right? You find the maximum distance from the hinge and pull or push, right? Why? It's quite obvious. Higher the distance, higher the moment, right? So here also, I have to find the highest distance from this point. This acts as the hinge, right? When this wheel rotates, it rotates around this point, right? It rotates around this point. I have to find the highest distance from this point, and that distance is 2r. And if that moment, so the moment then is F equals 2r. If that moment can counter this moment, mg into b, if the moment applied by me can counter this moment, then this can rotate, right? This can rotate, clear? If I can provide a moment which is equal to the opposite moment, then I can open the door, right? That is the basic idea. So I get F equals mgb over 2r. mgb over 2r, clear? This is the minimum force. Minimum force required. Clear? Clear? Write this down. Then let's again move into units and dimensions questions. And so, I mean, again, back to the initial topic. You, anyways, if you want to be successful, find something that you like, okay? I mean, for me, I like to do difficult stuff, creating a business, maybe creating a set of students who are like highly capable. It's again one of my targets. I mean, this what I'm doing is it's not financially intelligent. Okay, why? First day I start with a set of stupid questions, so I lose half of my students. Okay, in my class, usually first day I start with stupid set of stupid questions, then I usually lose half of my students. So which is financially really stupid. I don't care. Okay, I don't care. Okay, because I mean my target is to. I mean it's again one of my the series of my targets. Again, like if we can create a bunch of students who are really capable, who are able to think, who are really capable, who can do a massive change, then it's great. Okay, then it's great. So what I'm doing is not financially intelligent, but I don't care. Okay, because I have a different objective. I have a different objective. So and I really like that. Okay, I like creating stuff. I like doing difficult stuff. So if bunch of my students can do great stuff, if we can create a great Olympiad team, if we can one day win an Olympiad competition, if our students can create great businesses, if they can come up with great inventions, then it's great. Okay, so I don't care losing students. I mean I have nothing to do. It's a huge financial hit from my side, but I don't care. So you have to find something that you really like, that you can keep money aside and focus on that. Try to find that. Try to find something that you really like. Okay. I like doing difficult questions with students, and I'm really happy when even they can support those questions, when they can come up with answers. That means we have created a bunch of students who are really intelligent. Okay. I mean, I really enjoy that. So getting a financial hit, I mean, not a big issue in that case, because it's not my main idea about success. If I can create a bunch of students who are really capable, very intellectually capable, then I have done a great job. Question number 4. Question number 4. Exercise 4, question number 4. Then 5. Then if you are done with these two, try question number 6 and 7. Question number 4, 5, 6 and 7. Make it? Okay. You can try question number 4, 5, 6 and 7, exercise 4. Students who didn't understand this, pay attention. Again, uh, okay. I mean, I'll use a different example so that you can easily understand this. There's a hinge like this. Attention, everyone. Stop talking and try the questions. There's a hinge here. Assume that it's a door. And you have a door like this. Okay. And there's someone. Okay. Please be silent. And there's someone who's applying a force in this direction. This is the hinge of the door. There's someone who's applying a force in this direction. So if I need to open the door, what should I do? This person is trying to rotate it in this direction. I have to try to rotate it in opposite direction. Is that clear? If this is a door, if this is the hinge, if there's someone applying a force like this at this point, now it's difficult for me to open the door because of this force. Attention. So I have to provide an opposite force to open this. So if this is F2, if this length is L, oh, I'll take it as B now. If this length is B, if this length is 2R, and if this is F, to open the door, I should provide a moment which is equal to this moment, right? Clear? So what is this moment? F2 into B. What is the moment that I provide? F into 2R, right? F into 2R, clear? The moment created by me, F into 2R. This moment, F2 into B. So the force that I should apply is F2B into 2R. So in this case, F2 is the weight of the wheel. Clear? In this case, F2 is the weight of the wheel. That means mg. So it's mgb over 2R. Got the idea? So it's almost like a door rotating around this hinge. Nothing new. Clear? Just a door rotating around this hinge. Okay? Clear? Just the shape is different. Okay? Just the shape is different. Clear? And you have to find B. You have to find B. How can you find B? Pythagoras. Okay? Why? This distance is R. This height is A. If this height is A, if this is R, then this R minus A. Then you can apply Pythagoras law. R minus A squared, R minus A squared plus R minus A squared plus B squared equals R squared. R minus A squared plus B squared equals R squared. So B squared equals R squared minus R minus A squared. Then B equals R squared minus R minus A squared. Then I can put that B there. Okay. I mean, I have to calculate B. Attention. I know that this is R. This is R. This is A. Then this is R minus A. Then I can apply Pythagoras law. R minus A squared plus B squared equals R squared. Clear? R minus A squared plus B squared equals R squared. So I get B squared equals R squared minus R minus A squared. Then B is this one. then I can put that b, then I can put that b here. Clear? I can put that b here. Clear? Got the idea? Got the idea? Ah. So for the students who didn't understand, it's just like opening a door, okay? Now is that clear? It's just like opening a door, nothing new, okay? One person is applying a force in this direction. I have to provide opposite moment, that's all. Clear? Then I can open the door. This is just a door, okay? Just the shape is different. Clear? Now let's try exercise for question number 4. Write this down quickly, then I'll move to exercise for question number 4. And I mean, at the same time, when we talk about highly intellectual people, you may think that the class is for intelligent people. No, we have seen students understanding nothing for first 2 3 months, just keep struggling, trying again and again and again and again, then trying again, then try to figure out things, going home and studying again, then trying to do difficult questions, just keep struggling and turning into highly intellectual people. Okay, so the class is not for intelligent people, the class is for the students who like to be intelligent people. That's all. It's not for intelligent people. If a person is intelligent, there's nothing for me to do there. He will be anyways intelligent, he or she will be anyways intelligent. But what is fun is turning random students into intelligent students. For that, I'm doing my part, you have to do your part. You have to keep struggling, that's all. So let's move into exercise. Any other questions from mechanics tute? Anyone? 27. 7, 8. Ah, okay, for that you need resolution of vectors, right? You don't know how to resolve vectors, right? Not yet, right? Okay, attention. I'll do exercise for question number 4 and I'll give some pointers for you to try question 28. I'll give you some pointers to try question number 28. Then you can try that at home. F is the force required for a mass m to travel at a velocity v in a path of radius r. Obtain an expression for force F using dimensional analysis in terms of the above quantities. Consider the proportionality constant k equals 1. So they are telling that F is proportional, F depends on M, F depends on M, V velocity, radius, okay. Then they are telling that the proportionality constant is 1. Proportionality constant is 1. They are telling that the proportionality constant is 1. Mx, Vy, Rz. Mx, Vy, Rz. Clear? The proportionality constant is 1. Clear? Then dimensions must be equal. So dimensions of F equals dimensions of M to the power X, dimensions of V to the power Y, dimensions of R to the power Z. M to the power X, V to the power Y, R to the power Z. Then Uh, what is force? F. F is a force. That means M L T minus 2. M is a mass, right? M is a mass. That means capital M. M is a mass. That means capital M to the power X. V is a velocity. V is a velocity. Velocity means L T minus 1. Is that my phone? Velocity L T minus 1. Clear? No, right? M. I put air tags into all my bags and my purse and everything. So some stuff may start rigging all of a sudden. I always lose my bag. I always lose my purse. So I'm tired of that now. I have air tags everywhere. So force is mlt minus 2. mlt minus 2. This is m to the power x. Velocity lt minus 1 to the power y. Dimensions of velocity lt minus 1 r. R is a length. Attention, I need silence. Everyone. M lt minus 2. Here m to the power x. Here lt minus 1 to the power y. Here L to the power z. Clear? R is a length. Velocity is lt minus 1. Mass m. Clear? Clear? Just basic dimensions, okay? Then I can write here m. This is a force. M L T minus 2. Here it's m. Here you have x. That's all. Here L to the power y. Then here L to the power z. That means L to the power y plus L to the power z. Then here T to the power minus y. M to the power x, L to the power y plus z, T to the power minus y. Then here M to the power 1, L to the power 1, T to the power minus 2. T to the power minus 2. Then analyze the power M to the power 1. M power of M 1. Here it's x. So 1 equals x. Then L to the power 1. Here y plus z. Y plus z. Here T to the power minus 2 equals minus y. Minus y. So x equals 1, y plus z equals 1, minus y equals minus 2. Solving this, I get minus y equals minus 2. Then y equals 2. Y equals 2. Then when y equals 2, I can get z equals from this equation, z equals 1 minus y. 1 minus y. 1 minus y. Then I get 1 minus 2. That means minus 1. 1 minus 2. That means minus 1. Then x equals 1. X equals 1. Then f equals, here it's 1. M to the power x. That means m to the power 1. V to the power y. V to the power y means 2. R to the power z. R to the power z is minus 1. Then I get f equals m v squared over r. mv squared over r. Clear? F equals mv squared over r. Clear? All these equations are not imaginary equations. This is centripetal force in a rotational motion. You will find these things in mechanics. This is the equation for centripetal force in rotational motion. Write this down. So next week we can move to attention. We can do some more questions and we can do some more questions from this lesson and move to measuring instruments. So not next week, by the week after that, I'll start bringing measuring instruments. Then let's start doing practicals here. I'll break you guys into divide you guys into teams. Then maybe 10 students per day, let's try to do practicals. Otherwise, some students, they have to go school and do the practical, okay? So let's try to finish practicals here. Let's try to finish practicals here. We can start doing practicals not next week, the week after that. Maybe 10 students per day, something like that. So F equals mv squared over r. Do we have enough time to do one more question? No? I have to give some pointers about that question, right? Yes, really close. Yeah, then it's correct. Yeah, I got some correct answers also for that question. Attention, I'll give one or two pointers since you've asked this question, but this question will be a little bit, this is question number 28 in mechanics tube. Attention everyone. I'll give one or two pointers about this question, but I mean, if you won't try this question, otherwise you can skip this question because you don't know how to resolve vectors. Since you don't know how to resolve vectors, this question will be difficult, okay? That is the only reason. Since you don't know how to resolve vectors, how to break vectors into paths, this will be a little bit difficult. But I'll give some pointers only for the students who like to do this question, but otherwise you can skip this question because this question, only this question, is little bit out of your scope, out of your O-level scope. It's difficult for you to do this question using O-level knowledge only. Other questions, yes. If you use your O-level knowledge and use 10 days to think, then you can come up with the answer for any question, but not this one. This is a little bit difficult. If this angle is theta, this angle is theta, this tension is T. Attention, this force is T, right? So the basic idea is I can do something like this. You have weight of this object acting downwards. Attention. Then it's accelerating in this direction. F equals ma. Clear? So this tension is providing this acceleration. At the same time, it doesn't allow this to fall down, right? So this tension, I can break it into two directions, this one and this one. This component, I take it as Ty. This component, it's balancing the weight, right? This component, it's balancing the weight. This component, it's providing the acceleration. Clear? So the part you don't know is you can resolve vectors into two directions. That means if this is t, if this is theta, this component is t cos theta. This component is t sin theta. So t sin theta is providing the acceleration, t cos theta is balancing the weight, right? This is tension. Vertical component of this tension is balancing the weight. Horizontal component of the tension is providing the acceleration. So now you can try, but the problem is only this question, it's a mistake, okay? It's a mistake. It's out of your scope. Only question number 28, it's out of your scope because You don't know this part, right? Resolving vectors, t cos theta, t sin theta case, it's not in O levels. So without that knowledge, it's difficult for you to get the answer. So you can forget question number 28 only. You can try other questions in mechanics tube, all other questions. If you put enough time and struggle, it's possible to get answers from O level knowledge. Only question number 28, it's difficult. It's out of scope. Thank you. And next week also the papers will be start at 1:45. For the students who can't write the paper before the class, they can write the paper after the class. Thank you.